Hello everyone, I am Prabhu Reddy from Sri Venkateswara College of Engineering, Bengaluru, Department of A&C under the USN 1VE 23 EC076. Subject is AV Mathematics 3 for EC Engineering and the code is BMATEC301. The video's topic is limiting behavior of Fourier series. The limiting behavior of Fourier series. This presentation will explore the limiting behavior of Fourier series, investigating how these infinite sum of sines and cosines approximate functions and uncovering intriguing phenomena that arises. Introduction to Fourier series representing signals. Fourier series express functions as a sum of sine and cosine terms with varying frequencies and amplitudes. And let's see how it can be useful in science and in engineering. The Fourier series are widely used in signal processing, physics, and engineering to analyze and model periodic phenomena. Periodic functions and Fourier coefficients. Periodicity. A function is periodic if it repeats itself over a fixed interval. And coefficients. Fourier coefficients determine the amplitude and phase of each sine and cosine term. The coefficients are named as A0, An, Bn. And then there comes frequency domain. Fourier series decompose a function into its frequency components. Convergence of Fourier series. Let's see what is convergence and the types of convergence in Fourier series. Convergence, as more terms are included in the series, the approximation gets closer to the original function. The first type is pointwise convergence. It is a convergence when convergence occurs at specific points of the function. And then the second type is uniform convergence. It is the convergence across the entire domain of the function. Let's see a brief explanation of pointwise convergence. The Fourier series conversion to the function's value at each point in the domain is nothing but pointwise convergence. The convergence conditions for pointwise convergence is pointwise convergence requires certain conditions on the function such as continuity and bounded variation, and it occurs in Gibbs phenomenon. Gibbs phenomenon is nothing but overshooting which occurs near discontinuities and even with infinite terms. You can see the pointwise convergence figure on the left side of the slide. Now the second type of conversion is uniform convergence. The Fourier series converges uniformly to the function across its entire domain. The conditions for uniform convergence is uniform convergence requires stronger conditions on the function such as continuity and piecewise smoothness. The characteristic curve for the uniform convergence is shown on the right side of the slide. And then the impact of uniform convergence is that it implies the approximation is accurate across the entire domain. It nothing but it makes sure the approximation is accurate across the entire curve or domain. The Dirichlet conditions. The first condition is piecewise smoothness. The function has a finite number of discontinuities and is differentiable between them. The second is bounded variation. Function's total change over its period is finite. And then the third is convergence. If all the two conditions are met, the Fourier series converges pointwise. Gibbs phenomenon. Near to the discontinuities, the Fourier series approximation overshoots the function's value by a fixed percentage. The overshoot is approximately 9% of the jump in the function's value. Even with an infinite number of terms, the overshoot persists. The characteristic curve of a Gibbs phenomenon is already shown on the right side of the slide. Now comes the last topic of the video, applications of limiting behavior in signal processing. The first application which we are discussing is filtering. Fourier series are used to filter out unwanted frequencies from signals. Compression. Signal compression algorithms utilize Fourier series to represent data efficiently. Then is image processing. Fourier series are even applied in image processing tasks such as denoising and edge detection. Thank you everyone for watching the video. Everyone like, share the video and subscribe to my channel.